Hello everyone. In this video I'm going to show you how you do a quick ANOVA on a specific dataset using R. Once again, it makes sense when every time you start a new project to put everything in one folder. In this case I'm going to call it ANOVA. So let me see what's in here. I have my directory data and my directory results, and here is the code, aptly named ANOVA. So the first thing that you should always do is click on session and set your working directory to source file location, or basically choose the directory to get to where the code is at. In this case, it automatically takes me to the desktop Anova because that's what I was a moment ago, but you could always navigate to that and make sure you select the right folder. Alright, so my directory is set. I also need to use certain packages. For this specific example, I will be reading an Excel file, therefore I need the read Excel file. I will do a quick plot, so I need the ggplot, and perhaps I want to do some other manipulations later on, so that's why I need the libraries reader and reshape too. I always use my favorite library easy packages that make sure that all these packages are loaded correctly and there are no interferences. So let me run this too real quick. Okay, and it tells me that everything is great. Some of the packages are for an older version, but that's fine. You can always update them later. Now, this command, we've seen this before, reads an Excel file. It's read_Excel, and if you hover on it, if you go and check the help for this, you'll see that it has a bunch of arguments. Right now I'm keeping it simple, and I'm reading everything from sheet number 1. I'm saving it as df1. Let's go ahead and see what this one gives me. It gives me now a data set with 3,600 observations of 5 variables. And if I want to explore this a little bit, I have different sizes of plots and some other variables, but the one that you should focus on is the plant height. So I'm trying to figure out if plant height depends on the size of the plots that these plants were put in. You have 8, 16, 12, and 20, I believe, and we'll want to see if the plant height has something to do with this size. All right, first let's explore it with some side-by-side box plots. Since I'm going to be using size as the variable to generate the 4 different categories, I need to tell R to view that variable as a factor. So this next line informs R that size is a factor, and if you'd like, you can check the levels here by doing levels df1 size, and it's going to give you the different groupings. As you can see, you have 8, 12, 16, and 20. Alright, so what I'm going to do is I'm going to make a real quick box plot using the data frame 1 that I've created. The x coordinate is going to be the size, the y coordinate is going to be the height, plant height. I want to do a geometric box plot, and let's make the color blue. You can change all that if you'd like, or you just leave it empty to the default. I also want the label on the x-axis to be the plot size, and the label on the y-axis to be the plant height. Again, if you leave this empty, it's going to be size of plant height like this, but I want this specific spelling. You can even give it a title, or you can just leave it out. It doesn't really matter. I also want to use the simple theme with white background and simple lines, but of course you can play around and figure out the one that you like the most. Now, if you run it like this without giving it a name, the moment that this is generated, it's going to pop up around here, and you can see it. Now, it's not named, unfortunately, so it's not as easy to save it later on, but still R remembers the latest plot that you have created, and you can still invoke ggsave by saying ggsave and the file path, and it kind of remembers that you're ggsaving the last plot that was available. So if I run it, there is an image that has been saved under the subdirectory results with the name boxplot1. And if we navigate to that, here is the box plot in a very nice PDF that we can view and put into various papers and presentations and all that. Right? So here's the box plot of the plant heights side by side for the 4 different sites. All right. Now let's go ahead and try an analysis of variance. And in R, the analysis of variance is very, very straightforward. It's AOV, and you need to tell it what variable you're comparing the means of by, with this tilde here, what variable to create the groups in. You also need to tell it where to find the data. So in this case, it's going to look at the data frame 1. The groups are coming from size, and the one variable that we care about is plant height. I also named this analysis of variance process AV. So if I run this line, there's an object here, the AV that is generated. Now if I want to see the results, I can just print summary AV, and this will give me the results down here. But let's say I want to save these results in a text file. To do that, you can use the sync. The sync is a general command in R that says, all right, starting from here on, save whatever follows into the file Anova summary, and this could be a text or CSV or whatever, and that's going to be in the subdirectory results. So it's syncing whatever follows between sync open and sync close. In this case, it syncs the summary of AV. Alright, so let's run this one, see what happens. Everything seems to be okay. So if I go back and I check my results folder, now there's a text file here. It's called Anova summary, and this is a typical, Anova table that we expect. Alright, in this case, we see that the p-value is very, very small, so we reject the null hypothesis, right? Which means that at least one of these means is different than the others. Alright, now let's continue on with our code. Suppose you want to do the Tukey analysis afterwards. Again, you can just create a new sync now to save the results under the Tukey summary top text, and Tukey HST of the object AV is all you need to do in order to create the Tukey analysis. So if you print Tukey HST AV, this computes and prints the Tukey pairwise comparisons based on the Anova table that you generated up here. Right, so again, if we want to sync this between the two, there's a new table created, basically this table. Let me just go ahead and print it, this table, but it's now in results, and you also have it as a nice text which you can copy, paste, and insert. All right. Now as you can see, these are all the possible comparisons, and these are the adjusted p-values. That's more or less how you do a simple Anova in R.